Yeah. Now we will look at, let's say I start taking two variables together. This is now where we are entering into the predictions world. The world of predictive analytics or whatever we call as. Let's say here I want to do the relationship between two variables. Like if one is growing, is the other one growing or is it falling? Or vice versa. That kind of analysis I am very much interested in. So for that, from now what I'll do is we'll get into some other interesting data set. Take car sales. It's very interesting data for let's say car sales unprepared. All right. So I'll take this simple data. What it talks of is specific to US, different manufacturers of cars, their different models, and what sales have happened. How many were sold in the last year? Probably you can get it for our country also. All this data, probably if you do some kind of secondary research, all this data can be gathered. So all I am doing, all it is done in this data set is all the cars that are available in the market, all brands, everything. How many were sold in the last year? What was the resale value? And what is the type of that? Is it an automobile or a truck? So probably we can talk about SUVs, LUVs, all this kind of stuff. Then what is its price? And some of the features of the car. Engine power, engine size, horsepower, wheelbase. They are all taken. Fuel capacity, fuel efficiency, some of the factors are taken. Now this data set we'll use for various analysis now. For regression we'll use the same data set. For correlation, for some of the aspects we'll use this data set itself because it is very much apt probably to find relationship between the price and sales, or probably to determine the price based on these features. So for using in the context of correlations and regressions, this data set is very apt to go with. So that's where I would like to use this data set for our next few features discussion. Now, when I say correlation, it is primarily I am trying to find out the relationship between two scale variables. As we have done crosstab analysis as a relationship between two nominal or ordinal variables, the correlation will tell us how strong is the relationship between two scale variables. Why is this needed? If the relationship between two variables is very strong, if someone predicts this variable, the first variable, I can predict the second one easily because I know that the second one moves in some particular way with the first variable. If the first variable is going up, probably the second one also will go up by more or less the same percentage. If that's the case, I don't need to predict the second one. If first one is predicted, I can derive the value for the second one based on the first one. So from that standpoint, correlation becomes a very strong factor. And even if I have to build up my portfolio, this correlation plays a very important role. Some of them are moving in one direction. If they are going up, the others are going down. Probably packaging these two will give me a no profit, no loss behavior. Right? If one is going up and the other one is behaving as if it is going down, or vice versa, packaging these two could result in a no profit, no loss kind of a behavior. So, identifying the correlation, and also I should know, how much strongly are they linked? Because can I use this as an input for determining this? See, today, as a simple example with respect to this. Can I predict my sales based on the price? For that, what should I know? Are these two linked first of all? Right? Historically, I should know, is there any relationship between price and sales? Probably if I ask you theoretically, you may say high priced vehicles, they are not sold more. But my data may prove something else. Or my data might say there is no such relationship. Some high priced vehicles are sold heavily, whereas some low priced vehicles are not even sold much. So our historical, our gut feeling is something different, and what the data is establishing is something different. So my intention always is to understand whether any such kind of relationship exists between the variables or it does not exist. Right? That is the intention of doing a correlation. If that relationship exists, is it strong or weak? If that relationship does not exist, it means probably there is no point in saying price is dependent or sales is dependent on the price, which means sales is dependent on some other factors. To identify your factors which will have an influence on the output, correlation analysis becomes very handy. Right? So trying to find out the interrelationship between the various variables is what is the objective of correlation analysis. Right? So here in this case, I'll try to apply the correlation between the sales and price. These two, though you can do it between any two scale variables, right? I would like to find out what is the relationship between the sales and the price. I'll do it without transforming the data first, and I'll do it after transforming the data. I'll show you the difference between the two, to what extent transformation plays a key role in your analysis, that log transformations and all, because right now we have not transformed the data. We have not even checked for the normality, nothing. Right? Directly, let's say if I apply the correlation between these two, after that check for the normality, remove the outliers, and then apply for the test for normality, and then apply for the correlation. What difference you will get, we can see. Right? All right. What happened? Okay. So initially analyze, then I am going with correlate, bivariate correlation. Correlation between two variables. Partial and all I'll deal with regression. So there is a correlation between two variables. What are the two variables I am looking at? One is the price in thousands and the other one is sales in thousands. These are the two variables between which I want to find out the correlation. Rest all leave it out. These are the things. These are the two variables between which I want to find out the correlation. What is it saying? First of all, I need to see whether the correlation is significant or not. Right? Here, the significance level, whichever is coming out, here are null hypothesis when we go with the correlation, the equality. Right? So the equality is correlation equal to 0, which is no correlation at all. That is the null hypothesis in case of correlation. When I say correlation value equal to 0, it means there is no correlation. If the correlation is equal to 1, it's a perfect positive correlation. Maximum value can be 1. Minimum value can be -1. If the correlation is -1, I am saying perfect negative correlation. If one is going up, the other is definitely going down, and vice versa. Right? If the correlation is around 0, almost no correlation. Null hypothesis is this one. In case of correlation, alternate is it's not equal to. So it is either close to 1 or -1. Right? Either it is positively correlated or negatively correlated. So whenever we are testing for correlations here, the first thing we have to look at is what is the significance level. Instead of looking at the values, first observe the significance level. Is the significance level less than 0.05 or greater than 0.05? If it is less than 0.05, I will go with the alternate hypothesis. Alternate hypothesis is correlation not equal to 0. Correlation, if it is not equal to 0, then we are trying to find out what is it. If it is not equal to 0, we are trying to find out what is it, which is minus 0.30. Right? Minus 0.30 means there is a negative correlation. So if one is going up, the other is going down. If the price is going up, the sales are going down. Right? And because it is not close to -1, the value lies between -1 and +1. The more it is closer to -1, the stronger is the relationship. See, one I am saying there is a negative relation. But the more closer, magnitude wise, the more closer it is to -1, I'll say it's a very strong negative relationship. On the other side, if it is more closer to +1, I say it's a very strong positive relationship. Otherwise, I'll say there is a relationship, but it is weak. A weak negative relationship, minus 0.3. Now, here, let's say, in this case, it is showing minus 0.3. What happens is, when I use this data for my predicting purposes, it assumes that this is the kind of weak correlation that exists between these two elements, and the predictability also, the predictions. See, now what is my intention of doing this analysis? Tomorrow, if I increase the price by 10%, what will happen to my sales? I need to predict my number. Let's say today my price is 1000 rupees. Tomorrow, if I increase it to 1100, what would be the quantity I would be able to sell? Right? That is the intention of doing this analysis. The moment I know this is the price, what will happen to my sales? That's the reason why I am doing this analysis. Now, what is happening here? The relationship is not that strong. There is a relationship, at least I can say the price plays a key role in deciding the sales. There is a relationship between the two, but there is a weak relation. Probably, let's say, now I can go ahead with this as for the estimation purposes. But when I transform the data, let's say now I transform the data and try to do a similar kind of an analysis. Right? I transform this data, do a similar kind of analysis. First of all, to transform, I need to know whether the existing data is normal or not. So for that, quickly, let's say I am going with the descriptives, where I am looking at sale in 1000 as well as price in thousands. I am trying to find out their skewness and kurtosis. Just quickly repeating the steps which we have done yesterday on this data. Just